So in this lesson, we're going to be talking about the Pythagorean identities, some of the most important identities you'll see in pre-calculus, trigonometry, and even in calculus. And I actually have a list of them all here. And this is sort of a traditional way that they're listed, due to that they're kind of categorized in terms of what they equal and how they function. Now, that being said, they're actually all found from the first one. And the first one comes from the unit circle. I'll draw you a little diagram right here. And if you think about items on the unit circle, all of them are all simply triangles with a radius of 1. So if the radius is 1 right here, what happens is that if I use the Pythagorean theorem, where this is x and this is y, and I have x squared plus y squared equals r squared. Well, x is cosine, y is sine, and then r is 1 squared. Now, of course, it's out of order a little bit, which can be confusing because typically in trigonometry, we write sine first, as it is the first thing that we learned back in geometry. But I will say that it basically works like this. The x goes here, the y goes there, and it equals 1. So this actually comes from everything we did on the unit circle. So the question is, if this is the basic one, and again, in terms of memorizing, this is a lot to memorize, but you can learn one of them and then it can build the rest. So how do I go from here to 2 more? Well, let's take a look. It's actually fairly reasonable to do this. And what you do is what I would do is I would write this one down, and then on my quiz, I would start by, okay, what if I wanted to solve for sine? I would just subtract cosine squared. And if I subtracted cosine squared, this would cancel out, giving me sine squared theta is equal to 1 minus cosine squared theta. And this one right here, you can readily see that this one is the one that is produced right here. And believe it or not, this one is also made the same way very easily. If I subtract sine squared on both sides to solve for cosine squared, then this will cancel out, giving me cosine squared theta is equal to 1 minus sine squared theta. And that is how you get already, just doing some basic math from the first one, we already have a third of them understood very easily. So how do I get to the next one? Well, believe it or not, I can't add or subtract anymore. I've already done all that. So my next operation to cancel something out would be to divide. So if I were to divide sine by itself, that would give me 1. If I divided this by sine, because remember in math, you have whatever you divide on 1, you have to divide on all, keeping your algebraic properties satisfied. And so if I were to reduce this, remember when this cancels out, it doesn't actually cross out because there's actually a 1 right here, right? So you get 1. Cosine divided by sine is cotangent. If you want to go back to the first slide of these notes, you'll see that right there. And then 1 over sine on that first slide of the notes, that's equal to cosecant. And so you'll see that, believe it or not, this one, which is it produces all of them, that one, once I divided it, right, this one can be found right here, though it's written typically out of order because, as you can see, to keep it consistent, right, that is there. And sometimes you can also see this written as 1 plus cotangent. It kind of depends on the teacher. So I have 1 plus cotangent here, which over here we have 1 plus cotangent squared here. And over here we have cotangent squared plus 1. They're the same, so no big deal. All right, so following that same idea, I can then divide this instead by cosine. Okay, and that will cross out and give you 1. And then I do it the same thing to each term to keep those algebra properties the same. And so if I reduce this one, sine divided by cosine is tangent squared. Again, go back to that first slide of identities. This would be 1. And then 1 over cosine is actually secant squared. And so you can see that one pretty easily. This one is found right here. Secant squared is equal to tangent squared plus 1, or 1 plus tangent squared. You can see how the order, it kind of gets mixed up sometimes, okay? That being said, this is the way that sometimes it's written and sometimes they have the one first. It just depends, okay? The reason I don't write these with the one first is because you're about to see sometimes they have a negative on them, and that messes the math up sometimes in terms of how they're written. So this is the traditional way to write them, that you may see them written reversed from your teacher. So the question is, how do I get to the next two? Well, pretty easily. It's kind of cool. If I were to subtract cotangent here, so if I subtracted cotangent squared theta from here, you can see that that one right there, right, which would come out, see what I get here. I get 1 is equal to, this would cancel. So you get cosecant squared theta minus cotangent squared theta. And that one is up here, right? Cosecant minus cotangent is 1. And so it's kind of interesting. I'm highlighting them all so you can see where they all come from. So this one came from dividing by sign. So this one is connected to that one. All right. And then the next thing is, if I do the same thing here, if I subtract tangent squared from this one that I highlighted green, you can see, okay, that this would cancel out and I would be left with 1, because that would drop down, is equal to secant squared theta minus tangent squared theta. That's a terrible theta. Let me rewrite it. Okay, and so once I do that, I can easily see that that formula right there is now found right here. So they're typically grouped so that they all equal 1. And one of the things I need to tell you about is that you can see that some of them are positive and some of them are negative. The positive ones, the order doesn't matter again. So you could have 1 plus cotangent, but the negative ones, that order has to be preserved. If it's not, you'll see an example what to do. It's not the end of the world if you end up having tangent squared minus secant squared. It would just produce a negative. And you'll see that in the examples when I do them. So let's finish up how to get these, and then I'll look at some examples. So how do I get, for instance, this one to this one? Because these are obviously, you can kind of see that one obviously has cotangents in it, so they're related. Well, instead of subtracting cotangent here, I could have subtracted 1. So that one would have come from, if I were to go back, and instead of subtract 1 here, you can see I easily get cosecant squared minus 1. Easy, that's that one. And then here, if I subtracted 1, I would have gotten tangent squared is secant squared minus theta. And so there's how you get them all. My advice is memorize as many as you can, but the ones you can't memorize, know how to make them. All right, so we're going to look at how to use these examples in just a moment, and it will take care of the issue. Again, it's very important, two very important takeaways, okay? Number 1, order matters with negatives, okay? If you have a negative, man, you've really got to pay attention. And the second thing that's also super important, I'm going to star this one, is that these have to be squared. Okay, in order for them to be squared is how they work. So for instance, sine of theta does not equal 1 minus cosine, right? They have to, that's a logical fallacy kids make all the time. They have to be squared. This is not possible. All right, we're going to look at some examples next. Thanks for watching this one, and please make sure you watch the next one.